You're asked to build a data center by hand. Every server is racked manually, then each cable is plugged in one by one, and after that, every firewall rule is typed through a web console at 3 in the morning. Now imagine that somebody accidentally changes a single setting in production and nobody documents it. What could possibly go wrong? 6 weeks later, the system behaves differently for reasons no one can explain. That is what traditional infrastructure management feels like in many organizations. Infrastructure as code, IAC, exists to end that chaos by turning infrastructure into something you can read, review, test, and repeat with confidence. At its core, it's essentially the idea that infrastructure should be treated like software. Instead of clicking around dashboards or relying on tribal knowledge buried in a runbook, you describe your infrastructure in code. Store that code in version control, for example Git, and then let machines handle the repetitive execution. The mental model I want you to hold is this. IAC is a blueprint for a city, rather than a collection of ad hoc construction instructions. Once the blueprint exists, you can rebuild the same city again and again and again, in different locations, and you still get predictable results. When talking about infrastructure as code, we're really talking about describing the desired state of your infrastructure in a declarative way. Basically, you're not telling the system every individual step to follow. Instead, you're stating what the final outcome should look like, and the tooling works out how to get there. For example, you might define that you want 3 virtual machines. Those machines should live inside a private network. They should sit behind a load balancer, and they should use encrypted storage governed by specific firewall rules. Once that intent is captured, the IAC tool calculates how to move from the current state to that desired state. This is declarative. A useful analogy here is ordering furniture from a catalogue rather than building it plank by plank on site. You specify what you want, then you describe the size, the material, and the colour, and finally the supplier takes responsibility for the assembly. If you place the same order again, you receive the same product. This repeatability is central to IAC, and it's enforced through a property called idempotency. Idempotency means that when you run the same infrastructure code multiple times, you always converge on the same infrastructure. There's no unexpected side effects, and there is no slow drift away from what you originally intended. IAC became mainstream alongside cloud computing, but it's not limited to cloud platforms. In practice, it fits naturally into modern software engineering workflows because it relies on the same disciplines developers already trust. Infrastructure definitions live in Git. They are reviewed through pull requests, and over time, every change becomes traceable. When something breaks, you can see exactly when a change was introduced, understand why it happened, and if you desire it to be, you can roll it back in the same way you would roll back application code. Think of this as bringing infrastructure on the same factory assembly line as your software. First, code is committed. Next, it's automatically checked and validated. After that, it's promoted through environments such as development, staging, and production. There's no side doors and no secret manual steps. As a result, teams ship faster, systems behave more reliably, and late-night incidents caused by environment differences become far less common. In practice, an IAC workflow usually starts by writing configuration files that describe infrastructure resources. These resources might include networks, servers, databases, or access policies. But the key point is that they are all expressed in code. Typically, languages used are designed to be readable by humans. For example, YAML or HCL, while still being precise enough for machines to interpret. Once those definitions exist, they are committed to version control so the whole team can collaborate on them safely. When you execute an IAC tool, it first inspects the current state of the infrastructure. It then compares that real-world state with the desired state defined in the code. If something is missing, the tool creates it. If something exists but it's misconfigured, the tool can correct it. If something should no longer exist, the tool removes it in a controlled way. This process is similar to a surveyor walking through a building site with a blueprint in hand, checking what's already in place and what still needs to be built. This approach works just as well in cloud environments as it does on premises. In the cloud, it might mean provisioning virtual networks, then creating compute instances, and finally attaching managed databases. On premises, it might involve configuring virtual machines, setting up storage, and enforcing network policies through automation layers. In both cases, the source of truth remains the same. The code defines reality rather than the environment slowly diverging through manual changes. One of the most common uses of IAC is cloud infrastructure deployment. Instead of manually creating resources in AWS, Azure, or Google Cloud, teams define everything in code and then deploy entire environments in minutes. Because those environments are repeatable, spinning up a new test environment or expanding into a new region becomes straightforward and low risk. Another important use case is automated configuration management. Once infrastructure exists, servers and services still need to be configured correctly. Rather than logging into machines individually, engineers define how systems should behave. That definition might include which packages are installed, which services are running, and how applications are configured. The automation then applies those rules consistently through hundreds or even thousands of systems, removing the problem of so-called snowflake servers that behave differently for unclear reasons. IAC also plays a major role in container orchestration. In Kubernetes environments, everything from application deployments to networking rules, as well as scaling behavior, are all captured declaratively. Tooling allows teams to bundle complex Kubernetes configurations into reusable templates, which makes large-scale container platforms manageable instead of fragile. Finally, disaster recovery becomes far more realistic when infrastructure is defined as code. When a failure occurs, recovery is no longer about trying to remember what to rebuild under pressure. Instead, it becomes a matter of rerunning known and tested definitions to recreate systems in a new location. This dramatically reduces recovery time and lowers the risk of human error during high-stress incidents. Different tools exist in the IAC ecosystem because they address different layers of the problem. Some tools focus primarily on provisioning infrastructure, while others concentrate on configuring systems after they exist. The important thing is not memorizing tool names, but understanding the category each tool belongs to and how it fits into the overall workflow. Provisioning tools are responsible for defining and creating infrastructure resources, such as networks and servers. Configuration management tools, on the other hand, focus on what runs on those servers and how that behavior is maintained over time. In mature setups, these tools are chained together into a single automated pipeline that reliably turns code into running systems with minimal manual intervention. Infrastructure as code is no longer optional for teams operating at scale. As systems become more distributed and expectations around reliability continue to rise, manual infrastructure management simply does not hold up. IAC provides consistency, auditability, speed, which together form the foundation of modern digital platforms. Looking ahead, IAC is increasingly combined with policy as code, security automation, and continuous delivery practices. The goal is not just to build infrastructure quickly, the goal is to build it safely, predictably, and in a way that aligns technical decisions with business requirements. If this video helped, please like and subscribe and share with someone you might know that doesn't know about infrastructure as code.